Okay, so redoing number one, we're going to do the region bound by y equals x squared, x equals 1, and y equals 0, which is the x-axis. Okay, so we're talking about this region in here. Okay, and I'm going to rotate it about the line y equals -1. Okay, do you guys see the gap in here? That gap means that it's a hollow solid, which means I'm going to need big R and little r. Okay, so I'm going to draw, to find big R, you go from the axis of revolution, which is now the line y equals -1, to the outer curve on the original region, that's big R, and then axis of revolution to the inner curve on the original region, that's little r. Okay, and what I'm going to do here, because I'm revolving a line, about a line that's parallel to the x-axis, this is parallel to the x-axis. So I'm going to do pi, sorry, my pencil's not working, pi times the integral of big R squared minus little r squared dx. Okay, so big R squared minus little r squared because it's hollow, and dx because I'm going about a horizontal line that's parallel to the x-axis. When you go parallel to the x-axis, everything is x's. Okay, so now my volume, sorry, big R and little r, I'm going to be doing top minus bottom. So big R on top, it's touching y equals x squared. On bottom, it's touching the line -1. So I have x squared minus -1, which is x squared plus 1. Little r, on top, it's touching y equals 0. Minus, on bottom, it's touching the axis of revolution, which is y equals -1. And 0 minus -1 is +1. And so now my volume is going to be pi times the integral of big R squared, so x squared plus 1 squared, minus little r squared minus 1 squared dx, because I'm parallel to the x-axis. And everything is x's, so I check my x-axis for my bounds, and I'm going from 0 to 1. Okay? All right, let's look at number 2. Number 2, I've got the region bound by y equals x and y equals x squared, and I'm going about the line y equals 1. So y equals x looks like that. Y equals x squared is my parabola. Okay, and they intersect at 0 and at 1. Okay, so the region that I'm talking about is this region in here. Okay, now I'm going about the line y equals 1, which is up here now. And this is where I'm revolving about. Do you guys see this space in here? That's the gap. When it's a gap, it's hollow. When it's hollow, I need big R and little r. So I'm going to need what big R and little r are. All right. To figure out what they are, I'm going from the axis of revolution to the outer curve on the original region. This time I'm drawing down. Last time I drew up, this time I'm drawing down. So that's big R. Top, it's touching the axis of revolution. On bottom, it's touching the parabola. Little r goes from the axis of revolution to the inner curve on the original region. That's little r. Okay, so big R. Now everything, I'm going parallel to the x-axis. Okay, because it's parallel to the x-axis. Everything is going to be in terms of x. Okay, so big R, on top it's touching the axis of revolution, which is 1, minus on bottom it's touching the parabola, so minus x squared. Little r, on top it's touching 1, on bottom it's touching x. Okay, and so then my volume is going to be pi times the integral of big R squared minus little r squared dx, because I went parallel to the x-axis for my axis of revolution. And everything here is x's, so I check my x-axis for my bounds, and I'm going from 0 to 1. Okay, now for both of these things, if I had to integrate this by hand, I would have to FOIL out. And number 2 in particular, I'd have to FOIL out and combine like terms. Okay, before I integrated. So just be mindful of that. You can kind of think about what it would look like if I integrated. All right. Problem number 3 is the same original region, but it's a different axis of revolution. Okay, so I'm still crossed between y equals x and y equals x squared. So they still intersect at 0 and 1. This is still my original region. Okay, but instead of going about the line y equals 1, we're going to go about the line y equals 2. All right, and it's so much easier to see the gap here where I'm going to be hollow. Okay, so if I have hollow, I'm going to need big R and little r. I am going about a line that's parallel to the x-axis. So it's going to be in terms of x. Okay. Big R, I go from the axis of revolution to the outer curve on the original region. I'm drawing down again. There's big R. Little r, I go from axis of revolution to the inner curve on the original region. There's little r. So big R on top is touching 2, and on bottom it's touching y equals x squared. Little r on top is touching 2, and on bottom it's touching y equals x. And so my volume is going to be pi times the integral of big R squared minus little r squared dx, because I went parallel to the x-axis. And everything is x's, so I check my x-axis for bounds, and I'm going from 0 to 1. Okay. All right, for number 4, I want to get rid of this last part. I just want the region bound by x equals y squared and x equals 1 about the line x equals 1. Okay, so x equals y squared is my sideways parabola. So there's my sideways parabola. X equals 1 is a vertical line. And that's actually also going to be my axis of revolution. So this is my region. Okay, this is my axis of revolution. Okay, do you guys see how there's no gap there? It's just touching the axis of revolution. So that means it's solid. Okay, so sometimes when you revolve around a non-axis, you're going to create these solid shapes. Just like in the example that I did at the top of the page, I had two solid shapes. Okay, so if I rotate about that x-axis, I'm sorry, about that line x equals 1, I'm parallel, my axis of rotation is parallel to the y-axis, so everything's going to be dy. Okay, to find out, I'm just going to have one r because it's solid, and I'm going to draw from the axis revolution to the outer curve on the original region. So that's going this way now. Okay, anytime you're going about a vertical axis, you're going to do like right minus left stuff. So I'm going to have to do right minus left on this. On the right, it's touching the line x equals 1. On the left, it's touching the line x equals y squared. Okay, and then my volume is going to be pi times the integral of r squared dy, because it's about a vertical line. I'm revolving about a vertical line. Okay, and everything is y, so I check my y-axis for my bounds, and I'm going from -1 to +1 on the y-axis, because that's where those curves intersect. Okay. All right, and lastly, for example 5, I took the same region. I'm going to get rid of this part again. Same region, and I'm going about a different line. Okay, so I'm still doing x equals y squared, which is my sideways parabola, and x equals 1, which caps it here. And so this is still my original region. Okay, but now I'm rotating it about the line x equals -1. Okay, so two things. I see the gap. That's definitely hollow. So I'm going to need big R and little r. And I have a vertical axis, so this is parallel to the y-axis, so everything's going to be in terms of y. All right, so now if I do that, I'm going to need big R and little r. Okay, you always start from the axis of revolution, and I'm going to draw to the outer curve on the original region. So this time I'm drawing to the right, and that's big R. And little r goes from the axis of revolution, which is the line x equals negative 1 again, to the inner curve on the original region, and that's little r. So big R touching on the right is x equals 1, and on the left, it's x equals negative 1. So I have 1 minus negative 1, which is 2. Just cap that off. Little r, on the right, it's touching x equals y squared, and on the left, it's touching negative 1. So I have y squared plus 1 on that. And then my volume is going to be pi times the integral of big R squared minus little r squared dy, because it's parallel to the y-axis. And everything here is y, so I check my y-axis for my bounds, and I'm going from negative 1 to 1 again. Okay, so hopefully these examples give you guys a really good idea of what you're looking at and what you need and what you don't need. I'm not stressing about drawing these solids anymore. I do want you guys to make sure that you draw your original region and that you label both, either if it's a solid, just the radius, if it's a hollow solid, both big R and little r. And again, if you revolve around the x-axis or something parallel to the x-axis, everything is going to be in terms of x. And if you revolve around the y-axis or something parallel to the y-axis, everything is going to be in terms of y.